Okay, this video we're going to learn a special equation. It doesn't have a name, okay, but we are using standard enthalpy change of formation to help us to do the math. So for these special equations, okay, we have one condition in order to use this. Okay, that will be the equation given to you. Okay, that must have one target equation, and also we have for the rest of the equation given to you have to be in standard MVP change of formation. Just give you two examples. For example, this one. Okay, you can see that we got a table. Normally they will show you a table and telling you that this is formation and have some value on it. Okay, and then they give another equation which is not formation in general. It can be a reaction, it can be a combustion, just not formation. Okay, just an equation, non-formation equation. Okay, so another example, you see that again. Okay, you can see a table. Okay, we have formation here, and then this time we'll ask you to find the combustion of gases methoxymethane. So this one is a combustion, but it doesn't a problem because these are the formation. This is non-formation equation. Okay, so bear in mind. Okay, the target equation normally it will be it have to be a non-formation equation. Okay, so this is the condition to use this equation. Okay, so let's have a look of one of the examples. So right now, okay, we got a target equations. We're having sodium hydrogen carbonate and then becomes sodium carbonate, water, and CO2. Or in case you forgot what is this reaction, so we did learn this one in chapter 18. This is the baking soda reaction. Okay, so it is a thermal decomposition of baking soda. Okay, so baking soda with sodium hydrogen carbonate, we put it in oven, okay, and then we have some temperature, and it will become sodium carbonate and give carbon dioxide. So therefore the bread, okay, the dough, okay, it will rise and sponge. Okay, so this one, okay, will be the target equations. So right here, okay, you have to notice that, okay, the reactant, we just look at the equation above. So the reactants and the products, okay, because this is a balanced equation, we will notice that, okay, all the elements on the left hand side and right hand side, they should be the same. Okay, because it's a balanced equation. Not only the elements have to be the same, but also the number of atoms have to be the same because it's a balanced one. So that means that, okay, on the left hand side you find 2Na, on the right hand side you must be able to find 2Na. Okay, if you find 2C here, you should have 1C and 1C here. Okay, so this is the meaning of balanced equation. So if we think about this way, if the reactants and the products, the number of atoms and also the elements are the same, if we think of the constituent elements that making up the reactant and also making up the product, they should be the same. Okay, just think about this one. So for reactants, we should have 2Na, 2H, 2C, and then we have 6O. So if we write a formation equation, they must be coming from these constituent elements, and then they will form sodium hydrogen carbonate. Okay, and these constituent elements not only able to form these, but also they can also form sodium carbonate, water, carbon dioxide, like that. Okay, so you'll find that for these elements, they will be able to make these reactants, or they may be able to make these products. Okay, so by doing this, okay, we can construct a enthalpy change cycles. Okay, so right here, if I write a equations, I will tell that, okay, the clockwise one will be 2 times standard enthalpy change of formation of sodium hydrogen carbonate plus delta H. Can you see that? This one. Okay, and then the other side, okay, it will be 3 of the formation add together. So you will say, can I write that way? Yes, of course. Okay, but of course you can also break them down into stepwise. Okay, many arrows, that would be all right. But you know that they will form this one, and form this one. So therefore you just add them up together will do. So this one, okay, will be 2 times delta HF plus delta H, and then on the right hand side, okay, you have 3 formation add up together. Okay, so now you can see that the one on the left hand side, okay, you have the reactants. These are the reactants, okay, the reactant one. Okay, and then the product, okay, will be the one in green in color. Okay, so if we rearrange the equations written here, you'll find that, okay, the yellow one can be put on the right hand side. So you will have the products minus, why is minus? Because this one is positive. You put it there, will be negative, minus the reactant. Okay, so if we have this concept, then we can say that, okay, the delta H will then be all the formation of the products minus all the formation of the reactants. Okay, what is the product and reactant we are considering right now here? The product and reactant, we are, this one is very important, referring to the target equation. Which one is the target equation? The target equation must be the non-formation equation. Okay, so I'll just give you a few more examples, and you know what I'm talking about right now. So I'll just make a general concept of that. Okay, you have a reactant become product. This one will be the target equation. So this will be the target equation. This is a non-formation one. Okay, non-formation one. Okay, and then, okay, these reactant and products, they must be coming from the same constituent elements. So you have formation forming these reactants, or formation forming these products. Okay, so when you have this one, the green one, add together to be the left hand side, and this one will be the right hand side, we are just rearrange them. You'll find that the products minus reactant will equals to the delta HF. So it will be like this. Okay, so the equations, okay, you don't need to write it out actually. Okay, so but just want to explain what are these symbols. So this one is the summation. Summation means add up all the things. Okay, so if you have product 1, product 2, product 3, then, okay, your equation would then be formation of product 1 plus formation of product 2 plus formation of product 3. Okay, product 3, P3. Okay, and then you will minus the summation of the reactant. Say, for example, reactant, this time we have reactant 1 plus reactant 2. Then we'll have formation of reactant 1 plus formation of reactant 2. Okay, so this is how we use these equations. Okay, so now we'll try it out. Okay, so how we're going to use it. So let's have a look of the first examples. Okay, so before we consider using an equation, first of all, you have to check whether we can use this equation. Remember, the condition for using an equation, you should have a non-formation as a target equation. So we have this equation. So this is a non-formation target equation. So you got a target equation. And then after that, okay, other than the target equation, for the rest have to be formation information given to you. You see that for the rest of 4 of them, okay, all of them are formation. Okay, so basically the equations, we can use it. So say by Heck's law. Okay, so delta H equals to summation delta H product minus reactant. Okay, you have to remember it's a product minus reactant. So for this one, okay, do we need to write this equation? Actually, no need. Okay, as long as you know how to put the value into the equation, will do. So first of all, I will deal with the product first. Okay, product, we have these. Okay, so the first one, sodium carbonate, so it will be negative 1131. Okay, this one. Okay, so this is the sodium carbonate. Okay, you don't need to write this. Okay, I just want to let you see clear. Okay, and then you have to plus, because summation means plus, add up all the things. So you have water next. Okay, water will be negative 285.8. We have one water only. Okay, we have one water. Okay, and then, okay, we will have one CO2. One CO2 will be negative 393.5. So that will be 1 CO2. Okay, so this will be the product, and then you minus, very important, okay, minus the reactant. Okay, reactant side we have sodium hydrogen carbonate, but pay attention, we have 2 sodium hydrogen carbonate. For the rest, okay, it should be 1 1 1. Okay, so you see and see I multiply this one, but for this one, okay, I have 2, so therefore I will have sodium hydrogen carbonate, which is negative 947.7 times 2. Okay, so by solving these equations, okay, you will be able to find the answer, or the answer should be positive 85.1 kilojoule per mole. Okay, so you see that, okay, we don't need to construct a standard enthalpy change cycle, and basically, okay, you don't need to use a statement. Okay, and the most times like saving process is we don't need to express the equation into something like H2 plus half O2 to give H2O, and then C plus O2 becomes CO2. I don't need to express all these short form into the equation and then do the crossing. So you have to recognize this equation is absolutely extremely useful, okay, in MC. Okay, whenever you see all of them are F and then one of them are non-F, okay, then you can use this equation. Remember, it should be P minus R. So you may ask, can I express these equation and then into like this way? Okay, after I express them, and then I form a enthalpy cycle, enthalpy change cycle, or use the statement form to do the calculation. Of course, you can, okay? If you have a lot of time, you can do that, okay? But I don't prefer you to do so, okay? So just give you a few more examples. So self-test, okay, you can try to pause the videos, okay, and apply it first and cross-check, okay, with the answers that I'm going to do. So that will be quite helpful. So right now you can check the equation. Is it feasible to use it? Okay, you got formation, okay, and then we got a formation here as well. Okay, we got a formation here as well. Okay, and then we got a non-formation equation. So this have to be the target equation. This is the target equation. So this will be the reactant and this will be the product. Okay, so delta H, the first one, okay, will be the product, okay, with NO2. We got 4 of them, so therefore will be plus 33.9, and then we have 4 of them. Okay, so times 4, and then plus H2O, which is negative 285.8, with 6 of them, so we have times 6. So the whole thing is product minus reactant. So the formation for NX3, okay, so you have like negative 46 times 4. Okay, and then do we have the formation of oxygen? Remember, if you write formation of oxygen, actually it means that oxygen to form oxygen. They're the same things, so you will know that this one will be 0 kilojoule per mole. Okay, if it is an element, the formation of element in the standard state, it should be 0. Okay, so no matter how many of them, okay, it will be 0 here. Okay, so by doing so, okay, you will find the answers to be negative 1395.2 kilojoule per mole. Okay, so this is how we do the questions. Okay, so one key point is I just have to emphasize, if you have formations of elements, in the standard state, it have to be 0 kilojoule per mole because they are just doing themselves, okay? But remember, if you have like O3, then that will be non-zero because it is not their standard state. Got it? Okay, so this one, okay, the equation actually is not difficult to apply, okay? But sometimes when you look at a question, you may not realize that will be able to use those equations. This is a very, very, very good example. Okay, so pay attention to that. So number 1, okay, you can find that, oh, this is not a formation, and this is a non-formation equation, and it's something that you have a delta H given to you. Okay, and then you have formation. formation. So what is the question you're looking for? Oh, you're looking for formation. So actually right here, you still be able to use the formation equation, which is P minus R. Okay, but this is slightly different because the target equation will not be the one that you are required to look for the delta H. Okay, but actually the whole thing is the same. So let's see how we do it. Okay, so for me, I'll just make it simple, clear. I will write the target equation one more time. Remember, the target equation is not this one, because the target equation have to be non-formation equation. So therefore, I will write like this. This non-formation equation will be my target equation. And based on this, I will know that this is the reactant, this is the product. You just imagine if I identify a wrong target equation, then the reactant and products that are defined will be totally wrong. Okay, so that's why, okay, I have to find the target equation, very important. So what we're going to do right now, okay, we'll have the delta H equals to the product, okay, which is 6 times negative 393.5, that will be the CO2, plus 6 times negative 285.8, that is H2O. And then we'll minus the reactant, okay? The reactant we have formation of glucose. Yeah, I don't know what is that. Of course, we're looking for it, okay? And then we have the 6O2. 6O2, that means it is 0, okay? So it will be like that. So now we try to put the values into it, okay? We still have this one, where this will be the delta H for this particular reaction. So actually, we use this delta H to put it right here. So it will be negative 2,800, okay, and then we will do the rest, which will be 6 times negative 393.5 plus 6 times negative 285.8, and then we'll minus delta HF, okay? So what you need to do is just rearrange, okay, rearrange the positions of these values, and then you can find out the formation of the glucose, okay? So the answer for this one, okay, have to be negative 1,275.8 kilojoule per mole. Okay, so should be correct. So to summarize these videos, remember, okay, the condition to use the equation, you must have one target equation. Sometimes it can be combustion, and then plus N formation. You have many formation. So typical examples can be like this. Okay, you got a formation table given to you. Okay, so the equation, remember, it is products minus reactant. Just want to remind you, formation, okay, it will be P minus R. Next video, we are going to learn about, I'm not giving you information, I'm giving you combustion. For that time, okay, that will be reversed. That will be R minus P. Okay, you'll find that they are actually quite similar, okay, for these two equations, okay. But for me, okay, I will just memorize like this way, see whether it will be helpful to you, okay. Formation is a long one. Can you see that? Okay, formation, okay, so that will be a long alphabet. So therefore, you'll find that we'll also have a long alphabet come out first, okay. So it will be P minus R. Okay, if you are having a lot of formation given to you, then it will be P minus R. But okay, later on you learn that, okay, if you are giving a lot of combustion, okay, then at that time it will be C is a shorter one, okay, so therefore will be R first and then minus P. Okay, that means the reactant minus the product. Okay, so I'll just explain a little bit more, okay, in the next videos. No worry about that. Okay, so that's all for this video. Bye bye.